Look at these examples here. So before we went to lunch, we talked about the change of base formula. Again, top of page 9 here. So we can use the change of base to evaluate the logarithm. Log base 4 of 6. Remember, anytime you're asked to evaluate a logarithm, the question you're asking yourself is 4 raised to what power is equal to 6. You're always solving for the exponent for the base. So you can change your base into any base. So if you want to change it into the natural log, it would be the natural log of 6 divided by the natural log of 4. So again, if you do have an 83, you don't have the updated operating system, this is how you would have to type it in your calculator. So you just type in the natural log of 6 divided by the natural log of 4, and that gives us about 1.292. So what that says is if you take 4 and raise it to about the 1.292 power, that would be equal to 6. You can also use your common logarithm, so log of 6 divided by the log of 4, and you would come up with the same answer. So that's how your change of base formula works. And last year you had a lot of practice using your properties of logarithms to expand or condense expressions. So for example, when you take a look at 5a, log base 5 of x times y divided by z. Remember your quotient property of logarithms. You can break up this quotient and write it as a difference. So log base 5 of xy minus log base 5 of z. Remember doing this stuff last year? Now, can you break x times y up any further? Yes, because you can rewrite this as log base 5 of x plus log base 5 of y minus log base 5 of z. So we can use those properties to expand out an expression. So any questions on A? So let's take a look at B. Again, you can undo the quotient by using your quotient property of logarithms. So I can rewrite this as the natural log of 2x squared plus 2 minus the natural log of x to the third. Now, what can you do with this power for x to the third? You can use your power property of logs. What can you do with it? You can move it to the front. So write that as a product. Now, remember, you can't break up the addition sign inside the logarithm. But even though you don't exactly ignore it, if you can factor it, you may be able to write it as a product. So when you see a plus or a minus sign on the inside, before you say, okay, I'm done, I can't do any further, check to see if you can do any factoring. Is there any factoring you can do to 2x squared plus 2? Yeah, you can factor out of 2. So I have the natural log of 2 times x squared plus 1 minus 3 times the natural log of x. Because now notice you have a product on the inside of the logarithm. So now you can expand this out even further by writing this as the natural log of 2 plus natural log of x squared plus 1 minus 3 times the natural log of x. So when you see that plus or minus sign on the inside of the logarithms, before you immediately say you can't do anything else, if you can factor, do your factoring. All right, any questions on part B? Now when you take a look at part C, anytime you're dealing with logarithms and radicals, you always want to get rid of the radical sign and change them into fractional exponents. What is the square root equivalent to as a fractional exponent? 1/2. So I can rewrite this as the natural log of x divided by y to the third raised to the 1/2 power. So now I can use my power property of logarithms. I can move that 1/2 as the coefficient of the natural log. So 1/2 times the natural log of x over y to the third. Now I have a quotient on the inside, so I can use my quotient property and rewrite this as 1/2 times the natural log of x minus 1/2 times the natural log of y to the third. There's one more property I can use. What's that? I can use my what? Power property. So I can move that 3 to the front. So 1/2 times the natural log of x minus 3/2 times the natural log of y. So any questions on how you can use your properties of logarithms to expand? We could also go the other way. If we jump down to 6a, we can also use this to condense as well. So looking at 3/2 times log base 7 of z minus 2. Remember, anytime you see a coefficient, a number in front of your log, you want to move those powers back. That's a power. So I can rewrite this as log base 7 of z minus 2 raised to the 3/2 power. Nothing more I can do other than that 3/2. Always move in part B, move your powers back before you do your condensing using your quotient or product property. So I can move the 3 to the power of x, that would give me the natural log of x to the third. The 2 can be moved to the y, and then the 4 to the natural log of z to become the power of z. Now you just work left to right, start condensing left to right. Again, I can condense x, natural log of x to the third plus natural log of y squared through multiplication. And then I can divide by z to the fourth. Do any questions on how you can use those properties to condense? If you look at letter C, again, use your order of operations. When you see parentheses, condense inside the parentheses first. So looking here, I have the natural log of z plus natural log of z to the fifth. I can bring those together through multiplication. And I'm just going to go ahead and move that to the power of z minus 5. So I've condensed inside of my parentheses. So now what I can do is I can move my power 4. So I have the natural log of the quantity z times z plus 5, all raised to the fourth power, all over z minus 5 to the second. Remember, all of this is inside that single natural log. Obviously, if you had common factors, you could simplify it if you could, but there's no common factors. Remember, this expression would be equivalent if I raised this entire numerator to the power of 4. It is equivalent to the natural log of z to the fourth times z plus 5 to the fourth, all over z minus 5 squared. So remember, they are equivalent expressions there, just written different ways. Any questions on taking these expressions and condensing? All right, let's take a look at some other examples of properties. So here, they're giving me that the natural log of 2 is equal to a, natural log of 3 is b, natural log of 5 is c. So I want to use my properties and write each logarithm in terms of a, b, and c. So natural log of 3/5, so 3 is being divided by 5. So I can use my quotient property to write this as the natural log of 3 minus the natural log of 5. And with the information given, what is the natural log of 3 equal to? Natural log of 3 is b. Natural log of 5 is c, so b minus c. Now 18 is not one of the numbers up here. So I don't see an equivalency to natural log of 18. So the idea of using the properties of logarithms, however, I know I can expand products and quotients. Well, given my 3, 5, and 2, is there a way I could rewrite 18? Well, I know 18 is equal to 2 times 9, correct? And then what is 9 equal to? 9 is equal to 2 times 3 squared. So I can rewrite the natural log of 18 as the natural log of 2 times 3 squared. So now I can use my product property of logarithms and rewrite this as the natural log of 2 plus natural log of 3 squared. Again, using my properties of logarithms, I can take this 2 and write this as 2 times the natural log of 3. Any questions on how I got 2 times the natural log of 3? Now I can substitute. Natural log of 2 is a, plus natural log of 3 is b. And you would do letter C the same way with number 75, but you have to take that C root change from 1/3 power. Oh, look at D. Log base 5 of 3. Well, this logarithm has a base of 5, correct? Every single example has a base of what? E. So right away, before I can do anything, I'm going to have to change this base into what? E. I have to change it into E. I can't do anything because this is a log base 5. I'm stuck. So I can use my change of base formula. because somehow I've got to use this information, and all these are given in terms of base e. So remember, by your change of base formula, I can take the natural log of 3 divided by the natural log of 5. And then natural log of 3 is equal to b, natural log of 5 is equal to c. So remember, when you're given information, if your bases don't match up, that's what you have your change of base formula for, to get everything in the base that you need. So any questions on those types of problems using your properties? So these problems down here at the bottom are a little different than what you did last year. Express y as a function of x. The constant c is a positive number. When you see this phrase, express y as a function of x, all you're doing is solving for y. If they said express x as a function of y, you would solve for x. So what this question is asking you to do is just simply to solve each one of these expressions for y. Now, c you're going to get to know very well in calculus next year. He's just a constant. He represents a number. We don't know what number it represents. He's just a number. All right? So that's how we're going to treat c in these examples. So if you take a look at a, natural log of y is equal to negative 2x plus natural log of c. The problem is the y, what we're trying to solve for, is trapped inside the natural log. So somehow, some way, we've got to find the inverse property of the natural log. What is our inverse? It's the base of what? E. E to the x is our inverse of natural log. So you can do something, just like you can add and subtract to both sides of the equation, just like you take the log of both sides of the equation, you can do what we call exponentiate an equation. What that means is I can take this equation and raise it to the base of e. So in other words, I'm going to take this equation and put it as a power. So e raised to the natural log of y is equal to e to the negative 2x plus natural log of c. That's what we call exponentiating equation. All right? So now, looking on the left-hand side, e to the natural log of y. Well, e raised to the ln, what's going to happen? Those are going to cancel out. So I'm left with y is equal to e to the negative 2x plus natural log of c. Now remember what we just talked about with the properties of exponents. What happens when you see an addition sign in the exponent? You can break apart those properties of exponents. So when do we add exponents together? We add exponents together when we do what with our bases? Multiply. So I can rewrite the right-hand side as e to the negative 2x times e to the natural log of c. That's what I mean by a lot of times we're going to be undoing those properties of exponents. Well, what happens right here when we have e raised to the natural log of c? That's just going to leave us with what? C. So my final answer is e to the negative 2x times c. Or c times e to the negative 2x. Any questions on A? So looking at B, now before you exponentiate, before you raise everything to a base, condense. Use your properties of logarithms as much as you can, and condense. Squish it all together if you can. I couldn't do any squishing here because there was no ln in front of negative 2x, so there was no condensing I could do. But if you look at letter B, there's lots of condensing I could do on the right-hand side. First of all, I can take this 2 on the left-hand side and move it to the power of y. So I'll have the natural log of y squared. Equals. I can take this power of negative 1/2, move it to the power of x. So that'll give me the natural log of x to the negative 1/2. Again, I got plus 1/3 natural log of x squared plus 1. I can take that 1/3 and move it to the power of x squared plus 1. So all I did on the right was I just simply moved my powers. Now, notice what's happening on the right-hand side. I'm adding 3 different logarithms together. So what property can I use when I'm adding logarithms? I can squish these together through what operation? Multiplication. So it'd be x to the negative 1/2 times x squared plus 1 to the 1/3 times c. So now that I have this condensed down to a single logarithm on the right-hand side and on the left-hand side, now I can do that exponentiating to the equation. I can raise both sides to the base of e. Well, e raised to the natural log is going to leave me with just what? to the ln is just going to be what? Y squared. E to the ln is going to leave you with x to the negative 1/2 times x squared plus 1 to the 1/3 times c. I know we have the negative exponent. You can deal with the negative exponent right now, or wait, because are we finished solving for y just yet? No. So I know that I have a y squared, so what am I going to have to do to both sides? I'm going to have to take the square root. But I already have fractional exponents over here. So what's another way? Instead of taking the square root, I could raise both sides to the power of what? 1/2. So I could raise both sides to the power of 1/2. So why would, now again, if I'm raising this to the power of 1/2, again, I'm going to have a power to a power rule to use. So what am I going to do with those powers? I'm going to multiply them. So that's x to the negative 1/4 times x squared plus 1 to the 1/6. Now I could write c to the 1/2. Remember what I said. C is just an arbitrary number. We have no idea what it is. Whether I have c to the first, c to the 1/2, c to the 10th, c to the 20th, he's still going to represent a number. So you don't have to write that c to the 1/2 power here. All right? So there is your final answer. And get rid of your negative exponent. You have y is equal to x squared plus 1 to the 1/6 times c all over x to the 1/4. Any questions on these? Let's take a look at c. So I have natural log of y is equal to 2 ln of x minus the natural log of x plus 1 plus natural log of c. So now again, I'm going to move my power. You need to watch your parentheses really carefully when you're condensing. Remember, addition and subtraction are equal operations. I'm going to condense just left to right. So when I do my condensing, natural log of y is equal to the natural log. How do I bring the natural log of x squared minus the natural log of x plus 1 together? What operation am I going to use? Division. So that's going to be x squared over x plus 1. Plus the natural log of c means I'm going to do what? I'm going to multiply by c. There is a huge difference, guys, between what is written here versus this. These parentheses mean a lot. Because that's how you know whether or not the c is going to belong in the numerator or in the denominator. So right now, when you multiply by c, remember, c is actually a fraction over 1. So where is the c going to be, in the numerator or in the denominator? Numerator. So watch that when you're doing your condensing. And now I can exponentiate. So I have y is equal to x squared times c over x plus 1. So just make sure before you exponentiate, condense both sides of the equation as possible before you raise both sides of the basic. All right, so any questions on that? All right, so if you did not get a chance, guys, because I know we've been crazy this week, some of you have been without power,